All right, so if you can see my screen, okay, today we are going to be doing this topic on acids. Right, so acid reactions, there are quite a number. You need to know them. You need to also memorize quite a bit of things. There's a lot of application going on for this kind of topic. You need to learn about characteristic properties of acid. So must know how they react with metals, how they react with carbonates, how they actually react with alkalis. Okay, you need to learn to write equation. Word equation only for Sec 2. But of course, like I said, if let's say your teachers already started teaching you chemical equation, that is in fact not a bad thing, because when you go on to Sec 3, it wouldn't be so tough. Okay. What I know is from Sec 2 to Sec 3, right, the jump is huge. Okay, very, very, very big jump. It's very different from what you've learned in lower secondary. Okay, the demand is a lot higher, right? So word equation, if you can learn some chemical equation, will be good. Then write down the uses of the common acids. Okay, then state the type of acids they are found in everyday lives. So if you want me to compare this section with what you will learn in upper secondary, right, this is probably just about 15% of the whole thing. Yeah, you're going to learn a lot more. Yeah. So if you have your notes with you, I think you are able to also write down some notes later. Because you have to fill in the blank. Now, citric acid, okay, found inside our sour fruits, oranges, limes, lemons, all this. So citric acid is present in them. Of course, you know, the vitamin C, okay, also contains citric acid. Now you have the malic acid, okay, malic acid inside apples. Then of course you have the lactic acid, okay, lactic acid inside milk. Then of course, if you look at this vitamin C, right, because it's made of orange, yeah, there's some form of citric acid, but again, vitamin C on its own is actually called ascorbic acid. Okay, and then for the acid found in the stomach, if you can see that this is the stomach, good. If you cannot, I'm telling you now, this is actually the stomach. The stomach contains a form of acid that we also find in the science lab. It's called the hydrochloric acid. Hydrochloric acid is known as a strong acid. Okay, but the one that you can see in the science lab. So if your school has split up the lab into physics lab, chemistry lab, biology labs, right? In the chemistry lab, there's always this thing called the bench reagents. So you have many bottles of acids and alkalis and some common reagents there. One of the bottles will be hydrochloric acid. It is classified as a strong acid, but whatever that is placed on the bench that can be accessed by students easily, they have been diluted many times. Okay, so it is not so harmful if you accidentally touch it. Okay, but if you go to this fume cabinet, there's a particular cabinet, right? It's structured in such a way that it sucks up the fumes inside. So there are strong acids inside, and they are also known as concentrated acid, meaning they have not been diluted. So the moment you open the bottle of, let's say, hydrochloric acid, the concentrated type, you see a lot of fumes coming out. There's the acid fumes. So before you can do that, you need to turn on the power to activate the suction effect so that the fumes will all be sucked up. Okay, and they process the fumes before they release anything into the atmosphere. So not to worry, everything is very safe. If you are going to be using strong acid, concentrated acid, there are certain reactions that you need to use concentrated acid. Your teacher will advise you accordingly how to actually handle the acid. Follow the instructions very closely. Now, if your hand comes into contact with the fumes of the concentrated acid, you will soon start feeling, you know, the skin is itching away and you will want to scratch and you cannot resist the scratching. So your skin may turn very, very red. Okay, and if you don't wash your hands, okay, the acid can even eat into your skin. So one of my lab tech, she's always in contact with this kind of chemicals. So there was one incident where she touched concentrated alkali. Okay, so her skin actually seems to be eaten away by the alkali, and I could see the pink flesh underneath. Yeah, so that is how serious it can get. So quickly I asked her to go and see a doctor, and then, the doctor clean up the wound for her. Okay, doctor has their own ways of cleaning up, and then after that, bandage her hand. Okay, so I want all of you to take note. A concentrated acid is very, very dangerous. There will be cases where you're so tempted to want to go and play with the acid, but please don't. Okay, listen to the instruction of the teachers for good reasons, that you are not allowed to have access to them easily. Hi, Sheena. Sheena, can you turn on your camera? All right, you didn't miss much yet, just in case you think that you have missed quite a bit. Not a lot. We are still discussing about the common acids, and we talk about acids in the laboratory. Okay, so uses of commonly found acids in the lab. Okay, we have citric acid, we have hydrochloric acid, we have ethanoic acid. Okay, ethanoic acid is quite common. Even you can find it inside the kitchen. Okay, it's called vinegar. Okay, so when you smell vinegar, that pungent smell is a distinct smell of ethanoic acid. So in the science lab, when you open a bottle of ethanoic acid, you're going to have a similar vinegar smell. Okay, then we have nitric acid. Nitric acid is found commonly on the bench of the chemistry lab, on the benches of the chemistry lab. Okay, it is usually stored in a dark brown bottle. Phosphoric acid, not commonly found on the bench. You will have to use it sometimes, but not all the time. Now, sulfuric acid is also commonly found. So the three acids that are commonly placed on the table for you, on the bench for you, they are called the bench reagents, right? The three common acid will be hydrochloric acid, nitric acid, sulfuric acid. The rest of them, usually it's stored inside the preparatory room. Okay, the lab tech will look after the rest of the acids. So if you want to see what are their common uses, I mentioned, okay, citric acid, ascorbic acid, right? They are used to make vitamins. They are used as preservative and flavorings in food. So if you look at food label, sometimes you do see citric acid as one of the ingredient used for making or producing the food. Okay, hydrochloric acid helps us to remove rust. Before coating, before plating, sometimes we need to clean the metal such that it is really clean and shiny. So the way of cleaning is to pour some acid and then, of course, rub off the rust or whatever stain that is on it. Okay, ethanoic acid preserve food. Yep, the example I can think of now is the preserved ginger for the century egg. Okay, that is one thing I eat a lot, right? Then there's green chili. When you go and eat hor fun and stuff like that, there's green chili, right? It's sour and salty because it has been preserved in vinegar. All right, they added some salt, some sugar to adjust the taste. Now, nitric acid is used to make fertilizers and explosive. Now you can see the fertilizers are for nitric acid and phosphoric acid. They are spelled in different ways. Both are accepted, in case you're wondering. Phosphoric acid also to make fertilizers. Okay, it can actually help to prevent the rusting of iron. If you ask me, do we need to know these examples? Yes, you do. You can be asked, all right, to state examples of the uses of each of the acid. Sulfuric acid, okay, you can commonly find it in the car batteries. Car batteries are huge, okay? It's not like the common ones that we use, okay? Detergent also contains sulfuric acid. Plastics, fertilizers, okay? When I say they contain, they are actually used to make detergent, to make plastic, to make the fertilizers. Okay, it is also commonly used as a dehydrating agent. Okay, dehydrating means to remove water, to remove moisture. Okay, done copy. Sheena, you got the points down? Yeah. Right. So chemical formula, at your level, you need not know citric acid is C6H8O7. Okay. You need not know ethanoic acid, not at your level, but I didn't say higher level, no need. Higher level, you must know. Okay, but right now, it is good for you to remember hydrochloric acid is HCl. Okay, it contains hydrogen and chlorine. You noted that the L is actually written this way in a cursive manner because try to avoid, I think you have been told before, okay, try to avoid Cl like this, okay, because this L can be also seen as a capital I, right? Okay, so take note. We will write down Cl either this way, okay, or this way. It is encouraged. It is really encouraged in the exam. Okay, nitric acid, all right, it's HNO3, sulfuric acid, H2SO4. There's another name for each of them. Maybe I can write down for you. HCl, we can call this hydrogen chloride. HNO3, hydrogen nitrate, and then H2SO4, hydrogen sulfate. Okay, so these are the alternative names. If you see, sometimes they purposely write this way is to really test your understanding, whether you know that it's actually representation of each of the acid. All right. Okay, characteristics of acids. All acids have the following properties. They taste sour. It doesn't matter what kind of acid. They all taste sour. They can conduct electricity. Okay, they are corrosive. You can see here on the slide, there's this picture. Okay, then turns blue litmus paper red. Even though litmus paper looks pink in color, we call it red. Okay, we just standardize the term red. Blue litmus paper actually turns red. Reacts with metals, carbonates, and alkalis. Okay, so these are just some diagram representing their characteristics. So when we look at the chemical reaction of acid with metal, okay, something you need to take note of. Right, I see some of you copying the notes, so I'm waiting. No worries. Unluck, are you copying Unluck? Have you bought your Sec 2 textbooks? Do you all have the e-version? No, you didn't get the e-version. Oh, okay, you got the hard copy. I think that they have free access now, for 1 year. Okay, the e-copy of the textbook, check. Because why is it that they offer this? I think they are moving along this direction now where everything goes online. Okay, so there's no physical copy. You have your own PLD, right? Personal learning device. So maybe your teacher might even get you all to, you're collecting yours towards end of December. I see, Shina. Okay, so you can actually access your textbook using your PLD. Yeah, so I think that is their plan, if I'm not wrong. Okay, makes sense, right? Okay, now, acids react with metals to produce salt and hydrogen gas. You must know how they react. Okay, this salt is not the one that you eat in the kitchen. No, it's not found in your food. The salt actually is the salt that is formed after the chemical reaction. Okay, so it's a general term, salt. It doesn't mean it is the table salt that you eat. I hope you all understand this part. Important to know. Now, so acid plus metal, the generic word equation look like this, but when we put in the different examples of the acid or the metal, the salt will change. Hydrogen gas stays the same. This gas is always produced when you have acid reacting with metal.